I'm back again, and today we're going to be discussing conservation of mass. So yes, we're on conservation of mass. You have watched the first video. Now we're ending it. We're tying it all together. But this time we're going to be discussing conservation of mass with grams. Emphasis on the grams, right? So what we're first going to do, we're going to separate our paper. And I'm going to take a ruler. And I'm going to divide my paper straight down the middle. So far like this. And we want to have 8 sections with 4 sections on each side. So take my ruler. Here are the first 2. I'm going to draw a line right here. And draw 2, 4. We want a total of 8. And draw my last line right here. So like I said, we should have 4 sections on both sides. So we talked about chemical equations, right? So I'm going to start off with one simple equation. So we have our first example, which is going to be 2 KClO3, which produces 2 KCl plus O6. So in the last video, we discussed how to break down and count atoms, correct? To see if they were balanced or unbalanced, to see if both sides were equal or not, basically to see if it followed the conservation of mass law. But sometimes you may see questions where they will give you grams. So for example, let's say the first reactant. We have 100 grams, right? And then the second, we go to the right side, the products. This one will have 50 grams. And then, of course, they want to test you, right? They'll give you one with a question mark. Your job is to find the missing portion. So if you know what the conservation of mass, you know that both sides have to be equal, right? Both sides have to be balanced. So if you know this side has 100 grams, you already have a portion of the second one that has 50 grams. What is the missing piece? Let's say I want to have $100, right? I have 50 starting off with. How much more will I need to get in order to have 100? So, of course, you know you will have to subtract. $50 plus another $50 will give me 50 grams in this case. So, second problem. Let's do another example. Let's say I have another different chemical equation. I have 4Sb plus 3 molecules of oxygen. That was antimony. It produces Sb4 plus O6. So same thing. We have 48 grams, right? On my reactant side, I have 48 grams. I know that this portion right here, they tell us that this portion is going to be 52 grams. On my product side, I have 55 grams. And then here is the question mark. If I have 48 grams on my reactant sides, plus the 52 grams, right? And on my product side, I have 55 grams, and I'm trying to find that missing number. What are we going to have to do? So first, we're going to add this side, 48 grams plus 52. And if you have a calculator, please feel free to use it. 48 plus 52, that's going to give us 100. So I have exactly 100 grams on this side. And remember, we're still talking about the conservation of mass. So whatever I have on my product side, my reactant side, has to match what I have on my products, which is on the right. So if I have 100 and I have 55, that's a portion of it. How much more will I need from my 55 to get to 100? Of course, you know, we're going to do what? We're going to subtract. So that missing portion is going to be 45 grams. Here we go. Let me go ahead and get my red pen to make that stand out, right? Let's do one more example together. So another one. I have a different molecule. I have 2 calcium CO4. That produces 2 calcium O3 plus CO2. Now here come our gram part. On my reactant side, I have a total of 158 grams, right? So we're going to be working with this number. I have 158 grams. On my product side, they give us a small portion. We have to find out the remainder part. They give us 49 to work with. And of course, this is where our question mark will be. If I have 49, how much more will I need on top of my 49 to get to 158? I'm going to give you a moment to conjure it in your head. So you know we're going to have to do some subtraction. 158 minus 49. This missing piece has to be 109 grams. Because we're following the conservation of mass, right, you guys? That's the law we're following. So whatever the reactant side is going to be, my product side have to match it. My reactants and my products have to be equal. Is it balanced or unbalanced? They have to be balanced, right? So now you're going to practice a few by yourself. So we have a chemical equation of N2 plus 3H2. It produces 2NH3. Here's our question mark. Here's what they're going to provide, a portion of it for our left side. And over here, thinking about the conservation of mass, right, you guys? We have 252 grams. What is that missing portion? What's the missing link? Another example. We have CH4 plus 2O2 produces CO2 plus 2H2O. Here's what they provide. 75 grams. This portion, 200 grams. Here's our missing link. And here's the remaining portion. What could this missing link be? Next example, we have 2H2O3. It produces O2 plus to H2O. They provide you. We have 289 grams. This portion right here, our oxygen, that's 74 grams. Plus our missing link. What could this one be? Last two examples, you guys. So I have 6 molecules of carbon dioxide, CO2, plus 6 molecules of famous H2O. It produces C6H12O6 plus 6, oops, that's a minus sign, 6O2. If y'all remember, this is the equation for photosynthesis. But we have 40 grams. 50 grams. Glucose, right? C6H12O6, remember that? That's going to be 45 grams. And then here's our missing link. What could you be? Question mark. And then finally, our last problem. We have sodium plus chlorine, which forms together, makes table salt, the salt that we like on our steak, sodium chloride. We have 58 grams of sodium. Oh, this is the easiest one, you guys. We have 68 grams of chlorine. What is the missing link? Conservation of mass with grams. So look at your previous notes. If you need to, complete the remaining 5 problems. Take a picture, submit to me for a grade, and we were done. Talk to you later, you guys. Bye.